All right, so our last section in this chapter is graphing radical functions. And we're going to start with two main parent functions. So remember, parent function is the most basic function of that type of function. So in this case, the square root parent function is y equals the square root of x, because the square root of x is as basic as you can get. So we're going to use our t-charts to graph these, but we have to pay attention to what x values we're going to pick here. Because if we think about it, we can't do the square roots of negative numbers, so we're not going to have any negative x values because you'll just get an error. And we're not going to use imaginary here. So we're starting at 0. So that's going to be our first x value. And then our next one should be a number with the square root, and that just happens to be the number 1. But 2 and 3 do not have whole number square roots, so we're going to ignore 2 and 3 for now and go to 4, because that's the next perfect square. And then after 4, 5, 6, 7, and 8 also do not have whole number square roots, so we're going to just use 9 as the next number. Right? And because our x values on our graph over here do not go past 10, we're going to stop at 0, 1, 4, and 9. So now we're just plugging these x values in. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So these are our points that when we graph them are going to create the shape of our graph. Now, a square root function will always stay positive if it's just the parent function. So it's not going to go below 0, y equals 0, but it will keep going. Because we can have x be 225, which means y is 15. So it'll keep going up, but it won't go below 0. So the graph is going to look something like this. That wasn't the best one. It's hard to draw graphs with this tablet. There we go. So it's going to keep going up, but it's not going to go below the 0 point. So a couple of characteristics. Domain and range we've already talked about, so we're going to talk about endpoint. Endpoint is the point where it starts. It's going to end there and not go any further. So that endpoint is 0, 0 in this case. And then our domain, we just talked about, we cannot go below 0 because you can't do the square root of a negative number. So our domain is 0 to positive infinity. And then our range works the same way. You can't get a negative for your square roots. So our range is also 0 to infinity. Actually, I'm going to put square brackets around the zeros because you can have 0, and that's a definite answer. So this is what the parent function of a square root function looks like. It'll be this basic t-chart, this graph, and then these endpoint, domain, and range. Now the next parent function we're going to talk about is the cube root. So the cube root is a little different, especially when we pick the x values. So once again, with a cube root, technically, we can have negative numbers. All right. So we can pick 0 because 0 is one that's going to have a cube root. I'm going to put it in the middle this time. All right. Just a second here. Double checking something. Yeah. So the next number that has a cube root is also the same number that was next in square root, which is 1. And because we can have 1, that means we can have negative 1. All right. Now, 2, 3, 4, 5, 6, and 7. None of those have whole number cube roots. Yes, they count as part of our domain, but for the sake of filling in our table, we can't use anyone that doesn't have a whole number cube root. However, 8 does have a whole number cube root, so we're going to use 8 and negative 8. All right. So the cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. And now because these are negatives, so the cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. All right, so now we have our points to graph. So it looks like this. I'm really bad at drawing these. We'll just go with it. Maybe. There's that half. There's this half. There we go. Looks better that way. All right, so another name for endpoint is turning point, which we've already talked about a little bit this year. So the turning point is where it changes direction. So in this case, the turning point is here because it goes from it increases like this way, and then it flips direction and goes this way. So it's 0, 0 still. Now our domain is different because now we can go into the negative. So in this parent function, our domain is negative infinity to positive infinity. And our range now is also going to go down and involve the negative numbers. So it's negative infinity to positive infinity. All right, so these are the parent functions. That means these are the basic ones. We can add stuff to this so that it moves and shifts our function around the graph. So if we have, this is our general function here. So f of x equals a times the nth power of x minus h plus k. Each of these means something. So n is our index, x is our normal x that it always is, and then a, h, and k all mean things. Okay, and we've already kind of talked about h and k and a with other functions that we've had. So h is the horizontal shift, but because it's underneath the radical sign, it does the opposite of what you think it's going to. So positive shifts things to the left. So positive h means it's going to go to the left, and negative means it's going to shift to the right. And then k is the vertical shift, and it does what you think. So positive shifts up, negative shifts down. And then your end/turning point is the point negative h, so the opposite of the h, comma k. All right. So now we're going to talk about a. So because a does a couple things. So if a is negative, that means the function is reflected over the x-axis. All right. And then if you take the absolute value of a and it is greater than 1, it represents a vertical shift, which means the space between the y's is larger than the parent function. And then if the absolute value of a is between 0 and 1, that means it's vertical shrink, which means the distance between the y's are shorter. Okay. So we're going to do some examples here. So we're just going to describe the transformation of each function compared to the parent function. So in this case, for first, number 1, we have f of x equals the square root of x minus 7 plus 2. So our parent function is the square root of x. And so that means the negative 7 and the positive 2 are our transformations. So negative 7 is our h, which means it does the horizontal shift. And since it's underneath the radical sign, it does the opposite of what it says. So negative 7 means it's actually going to move to the right 7. And then the positive 2 represents k, which is the vertical shift, which means up or down. And it does what it says. So positive 2 means it's going to go up 2. And those are the only transformations in this function. So over here, for number 2, we have f of x equals 4 times the cube root of x minus 1. Now our parent function is the cube root of x. So we're looking at the 4 and the -1 as our transformations. So let's start with the -1. So it's not underneath the radical sign, which means it's k. So k does vertical shifts, and it follows the sign. So -1 means it's going to go down 1. All right, and then 4 is a. And since a is positive, it does not reflect. But now a is greater, the absolute value of a is greater than 1, which means this is a vertical stretch by 4, which means the space between the y values is going to be multiplied by 4. So for number 3, we have f of x equals the negative cube root of x plus 3. So our parent function is the cube root of x. So we're focusing on this negative and this positive 3. So the positive 3 is h, which means it does the opposite of what it says. So a positive is going to go to the left 3. And then the negative is actually a -1. So a equals -1. And the absolute value of that is 1. Okay, so it's not going to have a vertical or a horizontal stretch. We're more focused on the negative. So if a is negative, that means it's reflected over the x-axis. So this is reflected over the x-axis. And then those are the only two transformations for number 3. Now number 4, we have f of x. This v is a typo, you can ignore it. So f of x equals 1/2 times the square root of x minus 2 minus 6. So we're going to just start at h and work our way through all the letters. So h is the one underneath the radical sign, which is -2, which means because it's negative, it's going to do the opposite. So it is going right 2. And then this -6 is our vertical shift, and it does what it says. So it is going down 6. And then the 1/2 is a. And so because it is between 0 and 1, it is a vertical shrink. By 1/2. And there's no reflection because it's a positive 1/2. All right, so that's just describing the transformations. For number 5, we are given the transformations and we are going to write the function. So the square root parent function is reflected across the x-axis, then shifted 7 units left and 1 unit down. All right, so let's start with reflected over the x-axis. In order to be reflected, that means a has to be negative, so we need a negative there. And it doesn't say anything about vertically stretched or compressed, so that means a is -1. And then the square root, so we know it's just the square root, and then x has to go under here. And now h is the left or right, so we're going to look at this. So it's shifted 7 units to the left, which means it gets the opposite sign. So left is normally negative, but underneath here it becomes positive. So it's going to be +7. And then k, which is outside of here, is the up or down. So 1 unit down means we're going to go subtract 1. And then there is the equation that represents that function. All right, now, graphing. So we're going to graph these the way that we graphed exponential functions. We're going to write the t-chart for the parent function, and then we're going to create a second t-chart to do all of the transformations in. So we're just going to start with y equals the square root of x. So then this, we already know it's on the first example. So you can go back. Oops, I don't want 2 in there. I want 4. This is 2. All right, so this is the parent function, y equals the square root of x. Now, we're going to make some changes to it, just like we did with exponential functions. So, h is the one that changes the x's. So h is this one. So it's -1 underneath the radical sign, but it means it moves 1 to the right. So we are actually adding 1 to our x's. And then this negative is going to act like a -1 times all of that. So we're going to put the -1 with the y, because we're multiplying the y values. And then the +4 moves up or down, which is going to change the y's, and it stays the same, so you're just going to put the +4 here. So now we're going to take these x values and add 1 to them. So 0 plus 1 is 1, 1 plus 1 is 2, 4 plus 1 is 5, and 9 plus 1 is 10. And then we're going to take these y values and perform these functions. So -1 times 0 is still 0. 0 plus 4 is 4. 1 times -1 is -1. And then -1 plus 4 is 3. 2 times -1 is -2. Plus 4 is 2. And then -1 times 3 is -3. And -3 plus 4 is 1. So now these are the points that we're going to graph. All right, so 1, 4, 2, 3, 5, 2, and 10, 1. And there we go. So that is our graph of that function. Now, our end point, remember, is -h, okay? So it is this point right here. It's the first one right here. So it is 1, 4. And now our domain, we're focusing on this column right here for our domain. The lowest number in that is 1. And if you look over here in our graph, it's never going to go below 1. So our domain this time is 1 to positive infinity. And then our range, if you look, our highest y value is 4, and it's going to keep going down, 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 down. So our range starts at 4, and then we'll go towards negative infinity. And yes, it will eventually get down to negative, into the negatives, because these numbers will be large enough. So if you put 25 in, or 6, not 16, but if you put 25 in here, y is 5. So then -1 times 5 is -5, plus 4 is -1. So it's going to cross into the negatives there. So there is the graph of that function. All right, our next one is f of x equals 1/2 times the cube root of x plus 1 minus 5. So we're going to start with our parent function of the cube root of x. And remember, this time we can have negatives. And if you need to, go back to the second slide to get these values, because we got them on the first page, and they're never going to change. Oops. All right, so all of the changes are going to happen in our second t-chart. Okay, so x comes, the number with that comes from h, so it's +1 here, which means it's -1 here. The 1/2 times that goes in front of the y, and then the -5 comes down exactly the way it is. So now you're going to use these x values and subtract 1 from them. So -8 minus 1 is -9. -1 minus 1 is -2. 0 minus 1 is -1. 1 minus 1 is 0. 8 minus 1 is 7. And you're going to plug these values in for y. So 1/2 times -2 is -1. Minus 5 is -6. 1/2 times -1 is -1/2. Then -1/2 minus 5 is -5.5. 1/2 times 0, 0. 0 minus 5 is -5. 1/2 times 1 is 1, or 1/2, and then 1/2 minus 5 is -4.5. And then 1/2 times 2 is 1. 1 minus 5 is -4. And now these are your points. So -9, 6, -2, oh, whoops, that's a -6. So -9, -6, -2, -5.5, -1 is -5, 0 is -4.5. I forgot a number in here. Oh no, I didn't, we're good. And 7 is -4. And there we go. So if we draw this, it looks something like this. It looks almost like a flat line except this little bump in the middle. All right, so our end point is the opposite of h, so -1, k, -5. And our domain this time is -infinity to +infinity. And our range is also -infinity to +infinity. All right, moving on to number 8. I think we'll just go with it. If it's not in your notes, then you get a little bit extra practice. So we have y equals -2 times the square root of x minus 2 minus 3. So our parent function is the square root of x. Get that table from the first slide. So 0, 1, 2, and 9, and 0, 1. Don't know why I keep putting 2 there. It should be 4, because the 2 goes here, and 3. And now we need our second t-chart to do all of our transformations. All right, so with x, it's -2 here, so it means it's +2 here. We're going to bring the -2 down and multiply it by y, and then just bring the -3 down. So 0 plus 2 is 2. 1 plus 2 is 3. 4 plus 2 is 6. And 9 plus 2 is 11. And then you're going to plug the y values in. So -2 times 0 is 0. 0 minus 3 is -3. -2 times 1 is -2. And -2 minus 3 is -5. -2 times 2 is 4. -4. And -4 minus 3 is -7. Then -2 times 3 is -6. And then -6 minus 3 is -9. So these are our new points. So go ahead and graph those. So 2, -3, 3, -5, 6, -7, and 11, -9, which is going to be like here. So it looks something like this. Right? And if we want our endpoint, so it's the opposite of h, so 2, and then k, which is -3. The domain, so the smallest x value that we're going to use is 2. And we're going to use all of them up into infinity. And then our range, the highest y value we have is -3. I wrote that backwards. So the lowest one we have is -infinity, and it's going up to -3. There we go. Now it's the correct way. All right, I think that is all of the examples that we have. So have a good day.